everybody. So today's video is going to be about Module 2, Task 4, which is going to be about three big ideas. The first big idea is I can apply properties of operations, which is adding, subtracting, and multiplying to linear expressions in order to determine equivalence. Now, determine equivalence means decide if they're equal or not. The second target of today is I can evaluate linear and exponential expressions, so plug in numbers and get a value. And last but not least, I can use inverse operations to solve linear equations. So we're going to be solving equations today. As a warm-up or review, we're going to start by reviewing function notation. So we learned this in Module 1, and it's going to be coming back today as an important idea that we need to know in order to be successful with today's learning targets. So let's say I was given that g of n is equal to 3 to the nth power, and f of n is equal to 10 minus 6n, and I was asked to evaluate the following functions with the indicated values. Show your work for each problem. The first problem here says find g of 4. Now the important piece here is I do need to show my work in order to receive full credit. So g of 4 here means take the number 4 and plug it into the g of x function instead of all of the n's. So below here I would say g of 4. I'm plugging in the number 4 because there was an n in the equation, is equal to 3 to the 4th power. And again, I'm plugging in the number 4 because there was an n in the equation. Now I'm going to use my calculator and just type that in, and 3 to the 4th power would be 81. So that would be my final answer. To find f of 6, I would do something very similar, but just with the f of x function. So I would find all of the n's, and I would replace them with 6's, which means my function would be f of 6 is equal to 10 minus 6 parentheses, and I'm going to replace the n with a 6. Now, again, I'm going to type that into my calculator. So 10 minus 6 times 6 would be negative 26 as my final answer. Next, we're going to have f of 4. So I'm going to go back to my f of n function, and I'm going to replace all of the n's with negative 4. F of negative 4 is equal to 10 minus 6 times negative 4, which means I'm going to type that into my calculator, and I'm going to get 34. Last but not least, what if what you're asked to plug in doesn't have a number? It's something like this, where it says x plus 1. Again, I'm just going to plug the x plus 1 in instead of the n's. So I would have g of x plus 1 is equal to 3 to the x plus 1 power. Now, because I don't have a number here, it's not like 5 plus 1 or 6 plus 1, it's just x plus 1. I can't type this in. I'm not going to simplify it. That is actually my final answer, 3 to the x plus 1 power. All right, hopefully this helped to refresh your memory about function notation and how to evaluate functions. We are going to be using this again in this unit, so it's really important to kind of go back and review that a little bit. The next thing we're going to be doing is learning two kind of algebraic skills that help us simplify problems. One of the things we're going to need to do today is use these types of properties of operations in order to simplify a problem and see if it's equivalent or the same as another problem. The first algebraic skill we're going to review is distributing. Now, distributing helps us to eliminate parentheses. So if there is ever a parentheses in an equation and you want to get rid of it, you need to use distribution. When we distribute, we are multiplying by a number. And that's really important to remember that the operation here is multiplication. I like to think about distributing as passing out the number. So if you think about like if your teacher in class distributes a pile of papers, they're passing it out to everybody. And that's what we're doing here, but just with a number. So an example would be this. If I saw this expression and I wanted to simplify it to get rid of the parentheses, the first thing that I would do is distribute to get rid of the parentheses. So you'll see here that there's a -4 on the outside. If I distribute and multiply, I have -4 times 2, which makes -8x. Then if I distribute to the second term, I have -4 times -1, which would be +4. And this would be my simplified expression once I distribute. So again, I'm just distributing by passing this out and multiplying. -4 times 2 is -8, and then there's the x, and -4 times -1 is +4. Now, the second algebraic thing we're going to learn today is called combining like terms. So combining like terms helps us to simplify an expression. It just makes it look a little bit simpler because it helps us to condense those terms. Like terms are terms that have the same variable parts. Now, an important note here is that the numbers don't need to match in order to have like terms. So if I was looking at this expression and I said, let's find some like terms so that we could simplify. The first term here says 3x. So I'm going to look for any other terms that also have an x. In this case, that would be the -5x. If I combine those, 3x minus 5x would be -2x. You'll notice I didn't change the x, I just combined the 3 and the -5. I like to think about that as like 3 xylophones, take away 5 xylophones, you owe me 2 more xylophones, so -2x. If I look for some more like terms here, I could see that there's a +2y, and there's another term that has a y, which is this +6y. So 2 plus 6 would give me 8y when I combine those. Last but not least, we have this +9. Now that 9 doesn't have any like terms. There are no other terms here that have no variables. So I would just drop it like it's hot and copy down the +9. This would be my simplified expression. And you'll notice it does look simpler than what we started with. So that's why we say that combining like terms helps us to simplify an expression. Now, how are we going to use these two algebra skills? The way we're going to use them is to simplify expressions in order to determine if they're actually equivalent. So let's start today by just simplifying some expressions. For problem number 1, the directions say to simplify the expression by distributing and combining like terms. So we might have to distribute, we might not. We might have to combine like terms, we might not. It really depends on what we see as we work through the problem. In problem number 1, I'm going to notice that I see a parentheses, which means my first step is going to be to distribute because that will get rid of the parentheses for me. If I take the 2 and I distribute, I'm only going to distribute it to whatever's inside of the parentheses. The +6 is on the outside. If you're thinking about this as passing out a pile of papers, that's like a kid who's in the classroom next door. He doesn't get a copy because he's not in your class. We're only going to distribute to the inside of the parentheses because those are all the people in one classroom. So 2 times x would just be 2x. And 2 times -4 would be -8. Now with that +6, I'm going to do something that I call drop it like it's hot. So don't change anything, just drop it down. Then I'm going to look at that expression and I'm going to see if there are any like terms. I notice that the -8 and the +6 are like terms because neither of those has a variable. So the second step here is going to be to combine like terms. So -8 plus 6 would be -2. And the 2x doesn't need to change. So again, we're just going to drop it like it's hot. Just drop it down. Don't change anything. This would be your final answer, which is your simplified expression. Let's try another one. So for problem number 2, we have 3 parentheses x minus 1 and then minus 7. In order to do this problem, we're going to start by distributing to get rid of the parentheses. So again, the first step here is going to be to distribute. -3 times x would be -3x, and -3 times -1 would be +3. Remember, you're only distributing to the people in your class, so that -7 does not get distributed to. What we are going to do, though, is just drop it like it's hot. Don't change anything, just copy down the -7. Then we're going to combine like terms. Now you might be wondering, are there any like terms here? And there sure are. The +3 and the -7 both do not have a variable. So those would be like terms, which means I'm going to do 3 minus 7, and that gives me -4. And the -3x at the beginning doesn't need to change. So I'm just going to drop it like it's hot, and I get -3x. And that's my simplified expression. Next, we're going to do problem 3. So again, we're going to start by distributing. When we distribute here, we're going to do 1/2 times x and 1/2 times -6, which means we get 1/2 x, and half of 6 would just be -3. Now, this 5 doesn't need to change, so we're just going to drop it like it's hot. Don't change anything. Next, we're going to combine like terms. Which means we're going to combine the -3 and the +5, which gives me +2. Then that 1/2 x, we're just going to drop it like it's hot. Don't change anything. For our last practice problem here, we are going to start the same way. We're just going to distribute first. So when we distribute, we do 3/4 times x, which is 3/4x, and 3/4 times 8. Now, this is a chance where you might want to use your calculator if you're not sure, and the answer would be 6. And then you're just going to drop it like it's hot. Just copy down the +1. Next, we're going to combine like terms. And the like terms here would be the 6 and the 1. Together, they make 7. And as far as the 3/4 x, we're just going to drop it like it's hot. Don't change anything. And that would be my simplified expression. Okay, the last learning target for today is going to be, we're going to be solving equations. When we solve an equation, we are trying to find the value for a variable that makes the equation true. So for example, if I said, figure out what x should be, if x plus 3 is 5, you would say x has to be 2. And the reason I know that is because 2 plus 3 would make 5. It makes the equation true. In order to solve an equation, we use something called inverse operations to find the value of the variable. Because sometimes solving an equation is not as easy as just knowing that 2 plus 3 is 5. Operations are inverses when they undo each other. So for example, the inverse of add is subtract, and vice versa. The inverse of subtract is add. The inverse of multiply is divide, and vice versa. The inverse of divide is multiply. So if I wanted to solve this equation because I didn't know the number 2 off the top of my head, here's how I would do that. The first thing that I recommend is you always start by drawing a line through the equal sign. Now, the reason that I recommend that is that that line is like a wall. Whatever you do to one side of the wall, you must do to the other side in order to keep it balanced. Now, in order to solve this equation, I need to figure out how to undo a plus 3. In order to undo a plus 3, I would do minus 3 on both sides of the equation. When I do that, the 3's cancel. 5 minus 3 makes 2. And on the other side, the x is by itself, so I'm just going to drop it like it's hot, and I get 2. All right, we're going to go through a whole bunch of practice problems now just to make sure that we really know how to solve equations. And our equations are going to continue to get more complicated as we go, so it's really important that we practice kind of today so that we can add some more steps to this in the future. The first thing I would recommend for number 1 is drawing a line through the equal sign in order to remember that that's like a wall. It must stay balanced. So the left side, whatever you do to the left side, you have to do the right side. If I want to get a by itself, that means I need to figure out a way to undo the minus 5. Since the inverse of minus is plus, I would say plus 5 on both sides. Now that means that the 5's cancel, and 7 plus 5 gives me 12. Now, as far as the 1a, I'm just going to drop it like it's hot. Now, since 1a is the same thing as just a, that would be my final answer. I'm done. For problem 2, again, I would start by drawing a line through the equal sign. I need to figure out a way to undo the plus 10 so I can get x by itself. The inverse of plus 10 is minus 10. So I would subtract 10 on both sides. Now the 10s are going to cancel, and 30 minus 10 gives me 20. With the 1x, I'm just going to drop it like it's hot, and that's my final answer. For problem number 3, again, I'm going to start by drawing a line through the equal sign. Now this one's a little different because this means multiplication. Because there's no symbol there. There's no plus, there's no minus, there's no nothing. The inverse of multiplication is division. So in order to get g by itself, I need to divide by negative 1. Because the opposite of multiplying by negative 1 is dividing. That means that the negative 1's cancel, and 30 divided by negative 1 would be negative 30. Then I'm just going to drop down the g, don't change anything, drop it like it's hot, and that's my final answer. For problem number 3, I'm going to draw a line through my equal sign. Now, the x on this problem is on the right-hand side of the equal sign, which is totally fine. We still want to get x by itself. Negative 6x means negative 6 times x. So the opposite of multiplication is division. I would divide by negative 6. That means the negative 6's cancel, and negative 42 divided by negative 6 is 7. And as far as the x goes, I'm just going to drop it like it's hot. Don't change anything, and that's my answer. For problem number 4, this means negative 2/5 times b. Since the opposite of multiplication is division, I would divide by negative 2/5, and this might be a problem where you find a calculator to be helpful. Once I divide, the negative 2/5 cancels the negative 2/5, and 10 divided by negative 2/5 is negative 25. And with the b, I'm just going to drop it like it's hot. Don't change anything, and that's my answer. Last but not least, for problem number 5, I need to get the x by itself. The inverse of minus 8 is plus 8. So I'm going to do plus 8 on both sides, which means the negative 8 and the positive 8 cancel, and 12 plus 8 is 20. And as far as the x, I'm just going to drop it like it's hot, and that's the end. All right, that's the end of the video for today. Thank you guys so much for watching. I hope you have a great day, and I'll see you for some practice.